We're going to start lesson two, or chapter 2 today, excuse me. Lesson 2-1. We're going to be solving one-step equations. Before you get too far, make sure you put your name on your new packet and your hour. Don't put my name. All right, to solve an equation, you must isolate the variable. Remember, variables are things like x and y. They're not limited to those, but those are the ones that we think of often. We isolate a variable by using inverse operations. You see adding, the inverse of that would be subtracting. See multiplying, inverse of that would be dividing. So on this first problem, I am going to try to get this y by itself. I see a plus 2 or a positive 2. The inverse of plus a 2 is minus a 2. And then you have y equals -8. I think sometimes kids get confused about what it means to check an answer and what it means to find an answer. When you find an answer, you are proving it. Like when you are getting the answer for class, for an assignment, you need to prove the answer. Some of you guys think that when you check, you're doing it. So you look and you say, oh, I know -8 would make that true. -8 plus 2 is -6. If you're writing something like that or not showing a step and jumping to the answer, what you're doing is checking an answer that you already know and you're double checking it. And that's a good math skill. But what I need to teach you is how to undo operations so that we can get to those 6 and 7-step equations that you no longer can guess and check in your head. So as we're working today, I want you to really focus on the work, because the work is how I prove my answer, not just find it. I want to both find it, but prove it as well. Some people like to draw a line. You can do that or not. You're going to find your variable. This has a -8 or subtract 8. I think of it as a -8 a lot of times, like that. So I need to add 8 to make it zero out. I need to add 8. I need to see the opposite operation. Then I have m equals -6. Remember, when you're working with fractions, you need to have a common denominator. That's if you are adding or subtracting. If you're multiplying, you don't need that. So I have y on the other side, which is no big deal. I'm going to add 3/2. I'm going to add 3/2. And I'll get 1 and 3 make 4. Keep the same denominator, and I'll simplify that to be 2 equals y. Notice how all of my answers have a lined up look to them. Equal signs are lined up. Work is directly underneath, not to the side. I'm going to say that again. Work is underneath, not to the side. And then if I want, I can put a box around my final answer or highlight, whatever kind of makes your heart happy there. I'm going to work with 2 types of problems that sometimes kids feel they need a calculator for, but oftentimes you don't. Now I have multiplication going on. The inverse of multiply is divide. So I'm going to undo that multiplication and divide both sides by 15. Now this is the kind of problem right here where people stop and go, I don't know how many 15s are in 10. I don't know how to do that. You can just look at it like the fraction 10/15. So if you look at that fraction 10/15, ask yourself, can it be simplified? I'm going to go over here and make a little thought bubble, show you what I'm thinking. If I have 10/15 and I don't know the division answer, the answer will be the same as the simplified fraction. Divide. And I would get 2/3, 2/3. Now, if I were to have grabbed my calculator and said, well, what is 10 divided by 15? I would get 0.6 repeating, which is the same as 2/3. But if you say 0.6 repeating, a lot of times when you turn something into a decimal, it's not as accurate for the person working with it. If I say 0.6 repeating, A person's going to struggle to check that answer and plug that value in, but the fraction wouldn't be difficult. It's always accurate. Decimals are sometimes accurate because of our rounding techniques. So that's something to consider. Next problem, I see multiplication again, so I'm going to divide both sides by negative 3.2. Divide both sides by negative 3.2. Now again, I can grab a calculator and take 14 divided by 3.2 and get an answer that's a decimal. And as long as I don't round that decimal, it's only a couple places out, it's fine. You can also treat this like a fraction. This would have been negative 4.375. You can also treat this like a fraction again, and I'll show you what I mean by that. You can treat it as 14 over 3.2, slide the decimal over 1 in each, and get 140 over 32. And if you were to simplify that and ask yourself, well, what's the biggest thing that goes into each of these? Some people automatically start with the 2's and they say, well, I have 70 over 16. I have 35 over 8. And they just keep cutting in half until they can't anymore. 35 over 8 is the same as, negative, is the same as that as a decimal. You can also say, well, 8 goes into 35 4 times. I would have, that brings me to 32. That would then give me 3 left over out of 8. That and that are equivalent. So you can do the math division-wise like that by simplifying a fraction, or you can grab a calculator and do it. I just want to teach you guys ways to avoid using those calculators if you want to. They won't always be around for some tests, you know. All right. Here, whenever you see a problem with a fraction like that, that's division. You can treat it like a fraction or you can treat it like division. It depends on what you're up to mathematically. I want to do the opposite of divide here. I'm going to multiply. I'm going to use parentheses to do that. I'll multiply both sides by 3. Let's see, I have 3 times 10 and 3 times 9. That would be 30, 27, 57 equals R. That math I was just kind of thinking through in my head was 3, here's my thought, times 10 and 9 separately, 30 and 27. So I treated that like that so I could do the math in my head. This one is dividing by 9, so I'll want to multiply both sides by 9. Notice how I'm using parentheses. I'm putting them around the original problem. I'm showing my 9 on the side. I always show my work below except for multiplying. I show to the side. Notice how I don't add an extra time sign in. Don't do that. I'll have x equals 72. Likewise, when I was on this page back here, do you notice I didn't use this sign right there? Don't use that sign right there. Use a fraction to show your division. Don't use a division symbol. Use a fraction to show it. When you have not a number where the variable is part of the fraction, but where the variable is beside the fraction, you want to multiply by the reciprocal. Some people have a tendency to say, I'm going to divide by 3/4. So you might see on a person's paper that I have 12 divided by 3/4. Now you can show math like that, but that's not helpful. When we divide by fractions, we should multiply by the reciprocal. So my work will show that instead. So I'm going to put the 12 over 1 and then get 48 over 3. Or if you like, you can simplify before you multiply. It's kind of like a bonus in multiplying. You can only do that when you multiply. And you get 16 equals x. Had you gotten 48 over 3, you would have also simplified that to be 16. Remember, don't show that you're dividing by a fraction. Show that you are multiplying by the reciprocal. Don't draw an extra time sign. Use parentheses. Don't draw an extra divide sign. Make it a fraction. It is important that you do that. I'm going to stop here and then I will review these with you later.